Nice to be here. Welcome, everybody. We had 200 people show up, sign up, but rather I see that the high carb intake on lunch took a toll on the attention. But that's fine. That's good. We're going to talk about some pretty cool stuff, in our opinion, about OpAMP, Open Agent Management Protocol. I'm Panos.
Bob Johnson.
I'm the Observability Platform Engineering Director for Nike. And Bob is our principal. The way to think about the next 25 minutes is, so we're going to briefly go through what OpAMP is, and then go through the process of why you would think about, as an enterprise company, go through the process of thinking about building on top of OpAMP. What are the things that should be on top of your mind when going through that process? Because OpAMP is a spec and there is a reference implementation, but fundamentally you have to implement it in the context of your own environment. And then in the end, there's going to be a very interesting demo. And also we're going to talk a bit about tips and tricks for enterprise rollout strategy. We're going to spend a bit of time in this slide. So at Nike, and I'm sure there's much bigger companies than Nike as well out there when it comes to their OpenTelemetry footprint, we have about 90,000 OpenTelemetry collectors under management during, well, not under management, in our environments during holiday infrastructure scale right now. Today, literally on the 11th, is Singles Day in China, the single biggest retail event of the year around the globe, and our environments are scale. And we run collectors in gateway modes, which means there is a one-to-one relationship between services, applications, and OpenTelemetry collectors. The problem, of course, is that we have absolutely no way of managing those. Teams receive collectors as part of CI, and those collectors come with, let's say, an opinionated configuration. Teams can change that, but fundamentally we, as the centralized observability platform team, have no way of pushing changes to them. There's a bit of historical context here, which is at Nike, we use Splunk, right? Splunk is the biggest contributor in OpenTelemetry. But OpenTelemetry is a relatively new business, 6 to 8 years old. Prior to that, we used to have things like Smart Agent, right? Splunk Heavy Forwarders. So there was a control plane provided by the vendor there for those, but there is very little in terms of offering an equivalent in capabilities solution for the open source side. So for OpenTelemetry collectors, almost no one of the current vendors or indeed the open source ecosystem provides such a solution. OpAMP pretty much intends to change that, right? But OpAMP is a specification. So it's not an implementation. There is a reference Golang implementation, and then there is what we are going to talk about. But before that, let's get into the conversation of why we want to do that, right? This is a major endeavor. It's not something that's your weekend project. It's a multi-month effort at best. And you need to be able to reason internally about why you're doing this. There are probably other ways to tackle this kind of problem, which is to build some sort of control plane using infrastructure as code tools like Ansible, Puppet, Terraform, whatever. But the problem with these is that they will be completely custom and they will be super heavy in terms of state. So you would have to store some sort of mirror of your configuration files in some sort of blob storage, like Amazon S3. And fundamentally, it's just a shit ton of GitOps, if I'm honest. We actually examined that choice and we decided against it. There are also some proprietary solutions, but those usually involve quite a bit of money, and also you might get a bit of a vendor lock-in, and Nike Legal told me to not speak about them, so I can't really elaborate further. I don't want to diss them, I just can't talk about it. Okay, so OpAMP, right? CNCF-backed, vendor-agnostic network protocol specification for remote management of a fleet of agents. Crucial to say agents here and not just collectors, right? Theoretically speaking, you can do remote management of any type of agent so long as it's conformant to the network protocol. And now we're going to go through the cross-cutting concerns that we had to evaluate while building, taking what is essentially a reference implementation and just bringing it to life in the context of Nike and making it, let's say, enterprise-grade production ready. And Bob?
Sure. With OpAMP, it's really establishing a way for two different communication participants. You got the server and the agent. The protocol defines really specific structures so that the client, or the agent in this case, can give you back status. It can receive updates. It can tell lots of information about itself. From the server side, you also get to inform the agent of your capabilities. You get to tell it commands. You get to give it instructions for updating versions. You can deploy packages. You can restart. You can give it remote configuration. That's where a lot of the real features come in that we're really interested in. Because when you look at your fleet of agents out there, especially with large fleets, you'll find a huge variety of versions, vendor package names. You might have, varied actual OTel collectors out there. One from vendor 1, vendor 2, vendor 3, might even be an open source. So the protocol gives really good descriptions on how the system should talk to one another, the agents to the servers. Information that comes in the status messages, the responsibility of the agent is to first announce itself. And that's where a lot of the work and a lot of the resilience comes from, is that the agent is built to be resilient and retriable in its communications. Excuse me. The status information is both high level and low level. As you get into it, you can start seeing the more categories you have in your pipeline, or the more complicated your pipeline, the agent can actually report status down to those lower levels. That's something we saw as we evolved. We were first just interested in the top level. Hey, the agent's alive. Then when we started seeing some of the responses, oh, it's not only alive, but subsystem 1, 2, 3, processors, all that stuff came back. Main things that we're looking at are, from the OpAMP server side, the ability to push configurations, to confirm what the clients have, push new information down to them. Because we have basically a varied customer base out there, where we have people who can run with the standard configuration, but then other systems who might need something very unique and special. Maybe my file log receiver needs path 1 versus the Bob standard path. So basically being able to serve both the differentiated and the undifferentiated customers out there. I think we're good there. Once you have that communication established, the ability for the agents to talk to the server and back and forth, the next piece is, how do you make sure that you can trust the commands or the status updates that you're getting? So OpAMP provides a lot of options and a lot of layers of options to secure your communication and help guarantee that your agents are people that you should be listening to, and for the agent to trust that the server is someone they should take instructions from. As I mentioned, there's layers in it. Part of the instructions and the status messages going to and from the agent to the server include requests for sign my CSR. You can request that if you want to go beyond. You can layer it with additional header-based authentications to first establish, maybe a trust on first use. You've established some credential that you as a corporation can trust. You get in that front door, then you move on to the next levels of doing a certificate signing, and then you can get further, better trust once you go beyond that. OpAMP spec has a lot of details. This is a visual from the OpAMP spec itself, and it gives you at least 3 different options within that.
Yeah, this is probably the more mature one,
yeah.
Right? Yeah.
With all those options, there's a lot of choice and impact to you. Depending on what you want to do, if you're choosing certificate signing, you'd have to look at what's the size of your fleet, what's the, I don't know if veracity is the right word, how often would your fleet refresh and auto cycle itself? Depending on how you've got it set up to pay for your certificates, you might wind up running up a huge bill. If you're creating 100,000 servers, using the certificates and throwing them away when they scale down. So that's one of those things that you got to worry about and consider as you go through this. Let's see.
Yeah.
Okay. When you've got a couple options, and this is where some of the security comes on top of everything, depending on how you're deployed, you would need to consider a firewall if you're on the outside world, everything in layers. You have some more open options if you're choosing to just stay internal, don't have to pay that price. If you're involving a firewall, just be prepared. The OpAMP protocol specifies port 4320. That may or may not fly with your firewall provider if they say that that's a non-standard port. Be prepared for that. The protocol does allow, and the server implementations allow you to go change that. You just need to plan in advance. Don't get caught short-sighted on that. With the layout of an OpAMP server, the reference implementation that you'll see on the OpAMP Go just has basically a kitchen sink proof of concept or reference implementation. They have a server who has in-memory storage, and it's got a user interface. In the real world, you're going to wind up needing to go and scale yourself so that if you deploy, you're not going to have all your connected agents disconnecting, failing, waiting an extremely long time. So in the real world, you're going to need to plan for some resilience in the number of servers that you have, and plan and deal with the fact that your clients, those agents, are going to be talking to you over one of two primary communications mechanisms. I probably should have mentioned that earlier. WebSocket is what the primary and what you would hope that everyone connects with. The alternative is plain HTTP. With WebSocket, you're going to maintain full duplex communications. You're going to establish that connection, and it'll stay alive as long as your agent stays alive. So plan for that, but in the event that you need to redeploy one of your OpAMP servers, know that every WebSocket client attached to it is going to have to fail over to the next one. And we'll show you a little bit more in the demo, like what the communication is, what the chatter is between the agent and the server.
And I mean, you can employ typical node pooling techniques there, right, for handling WebSockets. And also, you can do none of this either, right? You can implement this and be completely stateless. So the choice is up to how important you think the system is fundamentally for you. But it's so lightweight and extremely fast, as you will get to see. Yeah. Okay, so let's say you've made the beautiful decision to go ahead with this. There are some things, or at least the way that we are thinking about this problem, is a phased approach, a phased rollout, right? It took us a few months to get the foundation going, pretty much the things that we just discussed. Phase 2 is to scale the solution to the first set, whatever that number is for you, of collectors, right? It's crucial to say here that for us, for example, the current collector that our customers internally was getting up till that point in time where we introduced OpAMP did not include the mechanism that would make those collectors visible to the OpAMP control plane and thus under remote management. That mechanism is the supervisor process, and we'll show that in action. So essentially, it's a process that you deploy alongside the collector that manages the collector essentially on behalf of the customer so that your end users, the service owners, don't have to restart stuff like the collector or their service or redeploy or do any sort of that engineering toil for no good reason. Once you establish that all the things that you want to do are good and nice, then you can move out to a full-scale rollout. And let's talk a bit about some of the steps here that the migration strategy from the previous situation to this new one, right? If your collector deployment topology is in gateway mode, as in I assume most people are, you need a way for those engineering teams to adopt what is either a completely new version of the OpenTelemetry collector or an entirely new, in our case, distribution, right? So we were using Splunk distribution up till that point, but we now have our own distribution of the OpenTelemetry collector, primarily because we want to include OpAMP-related stuff in it. So, and this capability during CI needs to be some sort of opt-in. Consider a build step that teams toggle, right? Because otherwise you're gonna break backwards functionality or compatibility, and this actually happened to us. So now, KPIs, right? I'm not gonna cover risk mitigation because we don't have a lot of time, and these are fairly typical things for any system. Success metrics, so KPIs are very important. You gotta be able to justify internally why you're building this, right? Some ways to think about that, I already mentioned one, which is the percentage of cost reduction related to engineering toil. But to be able to reasonably argue about that, you gotta be able to measure it, and that depends on whether your organization tracks things like DORA metrics, right? If you don't, then obviously it's a much harder discussion, but also it's a very tangible thing to say to a customer that, hey, if you make any deployment, any change to the configuration, you actually have to go in and redeploy. But if you adopt no OpAMP, you never have to do this again. That's a very tangible thing. Okay, and now it's time for the fun stuff. So we're gonna have a bit of demo, hands-on demo. Things are probably going to fail, but we're gonna try nonetheless. This is the reference design. You wanna go over it, Bob?
Yeah, and in Nike spirit, we just did it. We took the language that I know. The reference implementation was in Golang. I toyed around in Golang. I'm more familiar with Java. I've been doing Java for a long time. So I took the fundamentals, the protocol, and basically did the status update and the basics of custom capabilities messaging. So trying to get that, implement that in a Java pattern and think about it in a new way. And breaking it up so that it could be a little bit more real world for us, so that we had a full separation of the OpAMP server, moving into some persistent storage of the information to kind of keep track of the fleet, and then a rudimentary UI just to go and visualize what that would be. Trying to think in advance of what our agent management team or the fleet management team would need to do.
We should also say at this point that what you're about to see is not the solution we build internally, but it's like literally purpose-built for this, right? Okay, cool.
All right. So what we have here, good old Spring Boot. I implemented in Java. For the UI, it's simple. It talks to a backend MySQL database. And I am not a user interface guy, so bear with me on that. Panos laughs because it's true.
And it's JavaFX, so no judgment, right? Yeah.
Yep. I implemented the server in Java on Spring Boot. Quick and dirty searching. I'd never done WebSocket. It has a WebSocket starter. Guess what? It shows what we were trying to accomplish, that you can do at least the WebSocket protocol. One piece just in advance, what I found, at least my limitations and my Google research limitations after that, I had to draw a line around it. I couldn't get both WebSocket and plain HTTP running simultaneously on the same URI. There's probably ways to get it done within Spring Boot. I stopped at a certain amount of time. So we have the UI running, and here it is in all of its glorious form. Oh, look, it's already got me out there. I didn't clean up my database. So this is the UI. It's just showing that someone previously had connected. It's reading out of the state of the database. What we would have in reality would be a database pruner. So when agents have been disconnected for a period of time, they would drop out, we get rid of them. So this is not meant to be 100% perfect picture of your fleet at any instant. It's near real time, it's representative. And let me make sure, what else do I need running? Okay, so I've got the server. One of the first things that we did, because part of the understanding of this demonstration was learn more about the protocol. What are the actual words being used in the communication? Because hadn't seen it. Reading the spec, it would be good to touch and feel what those things actually are. So I took the OpAMP Go supervisor and pointed it at myself. So now if we look in the system, we now actually have the OpAMP Go, at the very least, allowed it to say hello, announce itself. And what we would get out of that information from the OpAMP supervisor would be, here's a unique ID. That unique ID, from what we've seen, it will be unique to each instance. If you're running on an EC2, it'll be brand new. If you were to restart that EC2, you're still just restarting it, that will be persisted. There's going to be some disk persistence for that. So this is really representing every instance that is scaled up and come to life. Inside the communication, this is one of the first announcement bits that it would send. The client, the agent, would send a whole lot of information about itself. If it was partnered up and it was operating in supervisor mode, it's going to be attempting to start a local OTel collector, and it's going to give you a picture of what that OTel's collector's effective config would look like, what it actually materialized as. It's going to give you some general information, and this is the identifying information. So this is where we were coming in and trying to look at how do we better understand our fleet once it's out there. Trying to understand, from our commerce domains to our consumer domains to everybody, we need to know more about the folks out there. Now that we have that, let me show my simulator. And again, JavaFX, I'm old. But what this shows, this is going to be emulating what an actual OpAMP client would look like. They're going to be having some configuration that identifies themselves, and we were toying around with how do we identify which microservice it was partnered up with. As Panos mentioned, we have them sitting an EC2 with a JVM, and you've got a partner OTel collector. So in this case, we need to know about which microservice that was about. So this information lets us go add to the configuration, identify, and now we'll have a little bit more information. And this one's operating, it's sending communication to our OpAMP server, recognizes that information was sent. Here's the JSON form of the protobuf of the OpAMP spec. And basically the agent is identifying what its capabilities are. And I think in this case, all I have is I am reporting status. That's my only capability as an agent. The agent would announce what it's capable of. The server also responds back with what it's capable of. Is it going to push config? Is it going to just handle statuses? In this case, it also tells me that it's able to implement the OpenTelemetry pause custom capability. We can go in and send more REST messages to it. I just increment, there's a sequence number in here. The sequence number is important. That's part of the resilience of the agent. So as I mentioned before, agents will, if something happens to the WebSocket or their own network or their host, if they get killed, they will come back. The server is responsible for keeping track of the last communication sequence number. If it ever goes out of sequence, in this case, my last sequence was 5. If I were to send another message, let me do this, let me mess with it. I'm incrementing the sequence. I just simulated a failure on the client. Now the server is going to respond with, tell me more about yourself. I lost track of you, so in case I didn't have anything, send me everything again. So that way your server just stays up to date and your agents will react accordingly when something goes wrong. This simulator also lets me do a connect and disconnect with WebSocket, same kind of communication, same kind of behavior with the sequence. So all this, we're still looking just at a fleet of a couple, and cool, we see some sequence numbers in here. Now if we get to more of that notion of fleet, the simulator does a little bit more than just that simple operation I shared. I trained it to do a basic announcement, go to sleep for a little bit, and then terminate itself. So from this perspective, I'm launching the fleet, I'm letting them drive around the ocean or whatever, and then eventually I'm going to recall that fleet. That's what we would see in the system. So if I launch this small fleet, we go back and we look at our system, now we've suddenly jumped to quite a bit more information. So I just launched a couple extra servers, and now I'm going off of something that I experienced over this vacation. I was at the Erie Canal and upstate New York, so I had Erie Canal locks. I had encountered some magnet fissures on the lock, and there were tugboats running out on Lake Ontario. But what this shows is from the client service and the client service namespace, me from the fleet management side, now I've got a lot more to slice and dice. So I can go and filter that information now that I at least have that and it started out sending me that information. Now I've got more to deal with. Because if I were operating on this, if Panos had come to me and said, go push a configuration update, I don't want to go and blast it to every single canal lock service out there. I probably want to go pick one, do a canary, test to see if it worked, and then if it did, I'd select the other ones who are not on the same version or not on the same configuration, and then incrementally release out. So what we did with this demonstration is stored this information in a database table called agent. This is where this information is persisted. I took those OpAMP basics and did a best effort to go persist. What we were also doing to learn about the communication was stored every single request and response into a table. This is not for production. This was for analysis and help yourself out. Let me go truncate these. And now if we look, we're back down to nothing. So all those just went away. Time check. Yep. So what I'll do is the last step, I'm going to launch a much larger fleet. So now, instantaneously, this just jumped up. So 1,300 WebSockets just established, and they started making their communications. So this particular one is already connected, sent 2 messages, and eventually it's going to go away. But this just shows with relatively straightforward, this was a really entertaining and fun exercise to go build. This is how you can set things up. This is how the agents respond, request. Yeah.
Yeah.
And that's it.
That was it.
This is just running on the laptop, and that tiny, relatively tiny scale, you can imagine what you can do on something with much more horsepower.
Yeah. Thank you very much. We might have some time for questions, I'm not sure. Okay. Oh, we have one over there. Oh, there is a microphone right over here.
Find yourself deploying one OpAMP cluster or multiple to handle different use cases? Or different teams?
So right now we're planning on one single cluster. We don't have it separated by team, by domain. So we've got it set up and we're scaling for one central input. But it's going to be geographic. So based on AWS partition, there would be one for North America, one for AWS CN as needed.
There are probably, this really depends on the number of, right? So there are some hard realities about the concurrency in WebSockets. For our scale, which as we said is tens of thousands, it's probably okay to do this. More than that, you're going to run into issues on the process side. You should probably have multiple.
Yeah. My other question is why WebSockets over HTTP? You said HTTP is an option.
Oh, sorry, can you speak closer to the microphone? I can't hear you.
Why WebSockets over HTTP?
Oh, okay. Primarily status updates, but yeah, go ahead.
Yeah, you're just establishing that two-way communication. It's full duplex, and it's going to be a permanent connection. So you're not having to go and make that reconnect, re-exchange all your TLS every single time.
Yeah, but was there a specific reason why you needed that full duplex all the time? Streaming communication, like.
One piece that I missed in the demo was what a standard communication looks like when you connect. From what we've measured, it takes about 13 to 14 communications, very quick. It's done within about 4 seconds, but there's initial blast of information that the agent has to send out. Server gives some information back. Check, status, and then you go to steady state.
There's essentially a checklist of messages in the very first establishment of communication between the two. That is unique to the first time. Yes, that's right.
Yep. After that, it's the standard configuration is the agent should reach out every 30 seconds.
Okay. Right.
So
Thank you.
Thank you.
Yep.
I'll only go if we still have time, because I know we're kind of running up against the clock. But real quick, the OpAMP specification for the agent actually calls out the ability to upgrade the agent itself, right? Running the supervisor as a secondary process, just for those, that allows you to, as a server, declare agent go upgrade, right? How do you find that, kind of two facets here, how do you find that conflicting with the infrastructure as code perspective, but also, do you find that agent upgrades are generally stable enough within the OTel collector standpoint, right? We find that collector upgrades can often change metric names. I mean, the CPU usage utilization metric is a great example where that shifted. Do you find that the specification is stable enough to be able to make those agent upgrades available?
As in the OpAMP specification?
Having OpAMP actually do the agent upgrade, right? So upgrading the collector version, is that something that Nike has done, or you guys have experience with, like implementing?
Well, we test it right now. Maybe in the future it will be a more futuristic situation. Right now, we test this kind of, let's say that there is a minor version of the OpenTelemetry Collector. We test that offline, not as part of a fleet deployment, right? That would be paranoid, exactly because of what you're saying.
Right.
Yeah, and I think we haven't dipped too far into the package deployment piece, but in that it's all certified. Basically we wouldn't release a version until we'd gone and done full testing. So that's going to be some of the responsibility for us. Take the delivery of the agent, make sure that we account for everything, and then go make that conscious decision to do a push.
We have considered giving our customers the possibility through a web UI of managing the scope of their own collectors, but we don't know how we feel about it. It's a conversation. More than likely, they're going to end up breaking them. So that's a reality. Yeah.
And it's a bit of trust and true identification. That fleet, how do you know that someone is the lock master service owner? Anyone could come in and claim that they are. So.
Great. Perfect. Thank you so much.
Sure.
Hi, I have a couple of questions. So, the first question is about
Closer to the microphone, please.
My first question is about the config management of your fleets, right? If you are managing different fleets, how are you managing the tenant isolation? Are you supporting tenant isolation at Nike?
That's a great question. We don't have that problem yet, in the sense that we deal with everything as a single fleet. We will definitely run into this problem soon. The commercial product, BindPlane, which is the kind of only player on the market, pretty much takes the approach that you mentioned, right? We will probably have to do something similar to mirror our business domains. Yes.
Okay. My follow-up question is: are there any plans for you to open source your?
I love that question. we have the intention of donating back to OpenTelemetry the Java reference implementation, right? If OpenTelemetry accepts us, that's great. There is currently only a Golang reference implementation. Beyond that, I'll defer to Nike Legal over here. We'll see. I don't know.
All right.
Yeah.
Thank you. Thank you. Good
Sure.
We're still good on time?
Do we need to hop off? 2 minutes?
2 minutes? Okay.
Yeah, I just want to go back to the question of how do you reason about pushing config out versus infrastructure as code? And what environments do you have those collectors deployed in, Kubernetes or like outside of Kubernetes?
Currently, it's ECS for us, right?
ECS, EC2, we have not dipped
That's
into-
where the control plane is.
Yeah.
Customers are everywhere, right, under the sun. Yeah.
Yep. But it has the capability of, pushing config or downloading config or pushing config into basically any workload. We've done configuration pushes into ECS and EC2. We haven't stepped into Kubernetes yet for any of the clients.
I think it really doesn't matter. What really matters is the ability to communicate in and out of network, whatever that means for your. Yeah. That's really is what makes or breaks things. Yeah. And for your first question, the problem is that again, you can do it. You can do it with infrastructure, and I'm sure many organizations might have similar solutions, especially for let's say proprietary or custom homemade solutions, right? It's just a lot of state management, and we would much rather not do that. Like if I was doing this demo, I wouldn't even have a SQL database, right? I would keep this completely stateless. So, but because it's possible to do so based on the protocol.
Yeah.
Like if you do, think about it, if you do one mistake, if there's some sort of mistake in consolidating the files, you don't know what's in the collector on the configuration, right? Yeah. Or you're pushing wrong stuff. Yeah.
I think we probably got to.
You mentioned being a Splunk shop, and so you talked about heavy forwarders. Are you replacing the heavy forwarders with OTel collectors? Do you have syslog sources?
Oh, that has already happened a long time ago.
Oh, so
yeah,
everything's OTel
we have the whole thing is on OpenTelemetry Collectors. But yes.